Good evening, good afternoon, good morning. This is Statistical and Geospatial Insight YouTube series. We are meeting in lesson number 8, which is about testing directional hypothesis part 2. By the end of this lesson, you'll be able to explain the difference between a left tail and right tail hypothesis. You should be able also to test directional hypothesis. A directional hypothesis is a type of testable hypothesis where it shows the direction of the prediction by looking at the relationship or the difference between the variable in a study. This is a hypothesis where the expected direction of the relationship or difference between variables such as an increase or decrease is stated. The hypothesis predicts a specific direction by showing whether the independent variables will have a positive or negative effect on the dependent variables. It uses specific language or keywords such as increase, decrease, more, less, higher, or lower. There are two types of this directional hypothesis, the left tail hypothesis and the right tail hypothesis. And this distinction is made on the basis of the location of the rejection region on the sampling distribution graphs. Now, by looking at this diagram here, look at the directional hypothesis. Let us start by looking at the right tail hypothesis. In both the right tail hypothesis and the left tail hypothesis, the null hypothesis, in the null hypothesis, the relationship between the variables is actually denoted by the equal sign because you are testing no difference, no effect, no correlation, and etc. Whereas by looking at the alternative hypothesis, especially in the right tail hypothesis, in the alternative hypothesis, uh, the means of one variable will be greater than the means of the other variables. And whereas in the left tail hypothesis, you'll find that the mean of one variable will be less than the mean of the other variables. Uh, Let us come and look at the directional hypothesis here. So by looking at this normal distribution graph, in the left tail hypothesis, you'll find that the critical region is located at this side here. What is the critical region? This is a very important region that usually determines the rejection. That is, the statistic in this region will determine whether the null hypothesis will be accepted or it will be rejected. Uh, if the the test statistics, that is to say, the probability of your test statistic is extreme, that is to say, it is less than the alpha set in this region, which is 0.05, this one will result to the rejection of the null hypothesis and the acceptance of the alternative hypothesis. Whereas in the right tail, the critical region is located at this region here, but we have the same assumption. We have an example for directional hypothesis about drug effectiveness. A study is testing a new medication for high blood pressure. The null hypothesis states that the new drug will have no significant effect on blood pressure, which means that the new drug, whether you use the placebo or the new drug, the effect on the blood pressure will remain the same. The alternative hypothesis is saying that the new drug will significantly decrease the blood pressure compared to a placebo. And this is actually what we want because we want a new drug to decrease the blood pressure. So in this study, which is randomized double-blind placebo-controlled study, we have participants, which is a large representative group of individuals with hypertension, and the intervention group received the new blood pressure medication, and you have the control group which receives the placebo, an inactive substance for blood pressure reduction. So a double-blind test or experiment, this is where neither the participant nor the researchers know who is receiving the active treatment compared to a placebo or control, And this method is used to prevent bias from affecting the result, as expectation of both the participants and the researchers can affect the outcomes of this study. Now, in this study here, first of all, let us look at the null hypothesis. So the average blood pressure for the individual that took the medication is equal to the average blood pressure to the individual that took the placebo, which means that there is no difference in the mean blood pressure between the intervention group and the placebo group. Or the new intervention or the new medication has no effect on blood pressure compared to the placebo. The alternative hypothesis is saying that the average blood pressure of the group that took the medication is less than the average blood pressure of the group that took the placebo. That's to say, the placebo does not do anything. It is inactive as far as the reduction of the blood pressure is concerned. So this means that the mean blood pressure in the intervention group is lower than in the placebo group, or the new medication has effect in lowering the blood pressure compared to the placebo. Here I have hypothetical data that I've created. So for the control, the placebo, here, and then you have for the intervention. I've considered the systolic blood pressure here. So now to analyze the difference between the average, the blood pressure for those who took medication and those who took placebo, we use the independent sample t-test. What is very important at the moment is that you just focus at the results, because we are going to have a session for all the, the means. So we are going to look at all the t-test and even ANOVA and all that. So here you have two tables. The first table is very important because it's documenting the means, that is the means for the blood pressure of those who took the medication and those who actually used the placebo. So for those who used the placebo, the mean blood pressure was found to be 150.57, whereas for those who took the medication, their blood pressure was found to be 125.21. Coming to this table here for independent sample t-test, we look at the significant level. The significant level is smaller than 0.05 or smaller than 0.025. In this case, we are going to reject the null hypothesis of saying that there is no, that is, the medication does not have any effect, because now we have enough evidence to support uh, the alternative hypothesis, which is saying that the medication has effect on lowering the blood pressure. Now, this is because when you substitute the mean here in the null hypothesis, you'll find that 125.21 is not equal actually to 150.57, or in the alternative hypothesis, the mean blood pressure for those who took medication is lower than the one that the people who took placebo. And this is the left tail hypothesis, because the relationship between the variable is denoted by the inequality less sign here. Therefore, in conclusion, in a one-tail hypothesis, the difference between left tail and right tail hypothesis lies in the location of the critical region on the sampling distribution graph, and this is determined by the greater than or the smaller than signs between the means of the variables. The type of hypothesis as to whether it is directional, that is left tail or right tail, or non-directional, depends on the expected study outcomes. Once more, thank you a lot to attend and participate in this lesson. See you in the next lesson. Please subscribe to my YouTube.